Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazim Ismail. My matric number is B071710545. My course is Bachelor of Mechanical Engineering Technology, Refrigeration and Air Conditioning Systems. My supervisor is Dr. Nazwani binti Muhtah. And today I would like to present about my bachelor degree project. Okay, my project title is Simulation Study on Design of Easy Shower for Bedridden Patient. Okay, Chapter 1, Introduction. Okay, problem statement. There are two problem statements. The first one is giving a bath to bedridden patients is very limited and burdensome for both caregiver and bedridden patient, and it requires caregivers' effort to perform the operation. The next one is the current method that the caregiver use for giving a bath to bedridden patient is a conventional method, and this method makes the time taken to give bath to the bedridden patient longer. Okay, there are three research objectives that is want to be achieved in this study. Okay, first one is to design a new model of easy shower for bedridden patient. Second is to analyze performance of design model of easy shower for bedridden patient by simulation method. And the third one is to evaluate the different value of velocity set with the design model of easy shower for bedridden patient. Okay, scope of research. This study will use simulation process to design and analyze the design shower and evaluate the different value of velocity set with the design of easy shower for bedridden patient. Chapter 2, Literature Review. Okay, bed bathing. Downey and Lloyd, 2008, stated that bed bathing can help manage the hygiene needs of bedridden patients. There are some important things that need to be care when doing bed bathing. First is cultural awareness and personal preferences. Caregivers should consider patients' preferences so that the bedridden patients will be in comfort condition. Next is privacy and dignity. Bed bathing is confidential and invasive procedure. Patients may feel uncomfortable or even irritated. Okay. Next, portable bathtub. To enhance self-esteem and muscle relaxation, portable bathtub offers comfort and well-being. Portable bathtub enable advancement, enhancement, and humanization in nursing care. Portable bathtub also has provided the nursing staff professional with greater cooperation and gratification. Okay, portable washing system consists of main device plugged into the supply of electrical current. Water is heated, stored, and pumped to the tube. An air bed with an outlet for the water flow mounted on the bed under the patient. Consists water temperature controller, which is 38 degrees Celsius to 42 degrees Celsius. Average flow rate of 5 liters per minute. Performed in about 8 minutes and 22 minutes using a power of 3 kilowatts of resistance. Caregiver have the product ready to give the bath in 30 minutes. Okay. Computational fluid dynamics or CFD. An analytical method for allowing rapid, efficient simulation of fluid flow and heat transfer. Can design fluid flow by mathematically resolving it using fundamental equation. All results are visually displayed. Common software used for CFD analysis is SolidWorks because it is easy to use and has many tools. Chapter 3, Methodology. Okay, survey template. This survey is done by using Google Form and it is distributed to 145 respondents. Okay, demographic survey data. Most of the respondents are female and aged 20 to 29 years old. Okay, this is the demographic survey data. Okay, specification survey result. Top 3 specifications were easy to handle, easy to use, and strength. Okay, based on the picture, the top 3 specification is easy to handle, easy to use, and strength. And the least specification is compact size. Okay, product comparison result. Okay, as we can see on the table or with weighted decision matrix, design A has the highest total score. It is because the product is easy to use, easy to handle, and it has a simple design and low cost. Concept design and final design. Okay, for concept design 1, it uses water pressure as it means, and it transfer water pressure from the supply water to the pressure chamber tank when it is filled from a hose bib. Okay, for concept design 2, it is same as concept design 1, but it has an addition which is the stand to support the tank, and function of the stand is to lift up the tank so it gives more pressure to the water to flow out. Okay, the concept design 3, it uses small water pump as its main. It may have benefit on terms of space because it is round and long shape. Okay, final design. Okay, design A obtained the highest score and had been chosen as the design that will be on simulation, but there are some modifications that has been made on the design A. The modification that has been made is on the position of the water inlet. The position of the water inlet is same as the position of the outlet. The modification has been made because of improvement on the water pressure. To minimize the loss of water pressure, the modification has been made by making the water inlet same as water outlet. Okay, for water outlet design model, there will be a hose connected to the inlet of the model design. Okay, this is the water inlet design model, and the water outlet design model, and there is a hose connected to the inlet at water outlet design model. Okay, flow simulation, it is made by using SolidWorks flow simulation. Two simulation conducted on the model. The first is simulation of water inlet, and the second simulation is simulation of water outlet, and it is included with the hose connected. Okay, boundary condition. Okay, for the analysis type, fluid, pressure, and temperature, the boundary condition for water inlet and water outlet is same. The analysis type is internal. The fluid is water. The pressure is 1325 Pascal, and the temperature is 293.2 Kelvin. But the velocity in y direction for water inlet is 5 meter per second, while the velocity in y direction for water outlet is 0.5 meter per second. Okay, parameter of the design model. Parameter that has been set is velocity. For each simulation, there will be a different value of velocity that is set as parameter. Okay, for simulation of water inlet, the velocity is 0.5, 2, and 5 meter per second. And for the simulation of water outlet, the velocity set is 0.5, 2, and 5 meter per second. Okay, this is the boundary condition set in the simulation. The boundary condition is inlet velocity and static pressure. Okay, and this is the boundary condition set for water outlet in the simulation. The boundary condition set is outlet velocity and environmental pressure. Chapter 4, Result and Discussion. Flow trajectories. Okay, this is the flow trajectories for simulation of water inlet. Refer to the velocity range. The velocity of 0.5 and 2 meter per second. The velocity inside the tank is at the middle range and at the lower range, while for the velocity of 5 meter per second, the velocity inside the tank is at the middle range and the higher range. Okay, this is the flow trajectories for simulation of water outlet. Okay, refer to the velocity range. The velocity of 0.5 and 2 meter per second at the lead and pipe head. The velocity inside the pipe head is at the middle range and at the lower range. For the tank, the velocity inside the tank is at the lower range. And for the pipe, the velocity inside the pipe is at the middle range. Okay, while for the velocity of 5 meter per second, at the lead and pipe head, the velocity inside it is at the middle range and at the higher range. For the tank, the velocity is at the lower range, and for the pipe, the velocity inside the pipe is at the middle range and the higher range. Okay, cut plot. Okay, this is the cut plot for simulation of water inlet. Okay, refer to the velocity range. For velocity of 0.5 and 2 meter per second, at the front section, middle section, and back section, the velocity inside the tank is at the lower range and at the middle range. While for the velocity of 5 meter per second, at the front section, middle section, and back section, the velocity inside the tank is at the middle range and higher range. Okay, this is the cut plot for simulation of water outlet. Okay, refer to the velocity range. For the velocity of 0.5, 2, and 5 meter per second, the velocity inside the tank is all at the lower range. And for the velocity 0.5 at the pipe head, the velocity is at the middle range and higher range. And for velocity 2 meter per second at the pipe head, the velocity also is at the middle range and the higher range. And for the velocity of 5 meter per second at the pipe head, the velocity also is at the middle range and the higher range. And for the pipe, for the velocity of 0.5, 2, and 5 meter per second, the velocity inside the pipe is at the middle range and higher range. Discussion. Okay, for simulation of water inlet, the velocity set is 0.5 meter per second, and the result obtained is 0.558 meter per second. And the velocity next, the velocity set is 2 meter per second, and the result obtained is 2.247 meter per second. Next, the velocity set is 5 meter per second, and the result obtained is 5.708 meter per second. Okay, for simulation of water outlet, the velocity set is 0.5 meter per second, and the result obtained is 2.941 meter per second. Next, the velocity set is 2 meter per second, and the result obtained is 10.003 meter per second. And next, the velocity set is 5 meter per second, and the result obtained is 27.720 meter per second. Okay. For simulation of water inlet, all the results obtained were within the value of velocity set, which is 0.5, 2, and 5 meter per second. Okay, it shows that the design model is convenient with the parameter set and the boundary condition chosen. Okay, for the water outlet simulation, all the results obtained were really distant from the value of velocity set, which is 0.5, 2, and 5 meter per second. Okay, this is because of vortex. The vortex crosses the opening pressure and has affect the flow, and the result, the vortex occur because of the design model. The proposed design model were not really convenient with the parameter set and boundary condition chosen, and also not convenient with the flow of simulation. Better result can be obtained if there are some modification can be made on the vortex. The vortex also can be avoided or removed by modifying the design model. Like example, adding a geometry on the design model, or modifying the design model by releasing the vortex to the pseudo external environment. Okay, based on the picture, the vortex is located at the end of the pipe head and at the corner of the pipe head. Okay, to remove the vortex, you can adding a geometry, or we release the vortex to the pseudo external environment. Chapter 5, Conclusion. Okay, this thesis presents a new design model of easy shower for bedridden patients. Okay, all the process of design and simulation is being done by using SolidWorks software. Okay, the proposed methodology is effective in order to obtain good results utilizing only fairly accurate information. Okay, the first contribution of this thesis is to support and help the bedridden community in their daily routine and take care of their personal hygiene. Sometimes there is a situation where the bedridden patient must do their daily routine and take care of themselves on their own. This thesis could be the guide or reference for bedridden patients to do their daily routine and take care of themselves. The second contribution of the thesis is to develop a technology that can help the caregiver minimize their energy usage in taking care of the bedridden patient, especially on bed bathing. In addition, this thesis is to propose the development of bath mechanism for bedridden patient so that either the bedridden patient or the caregiver get the large benefit in managing the bedridden patients. Okay, that's all from me. Thank you.